Okay, so we're continuing on page 4. And this says, when I make pancakes, I use a recipe. The recipe changes depending on how many people are eating breakfast. So if I have 1 egg, I use 2 cups of milk. 3 eggs, I use 6 cups of milk. 12 eggs, I use 24 cups of milk. And I want to see if this is a proportional relationship. So I look at y over x, because I know if y over x is constant, then I have a proportional relationship. So here, 2 over 1 equals 2. 6 over 3 equals 2. 24 over 12 equals 2. And my constant of variation sometimes called the constant of proportionality, is 2. And it relates x and y. So I know that y equals 2x, because I do know that y equals ax is my direct variation equation, or we could say y equals mx plus b, where m is the slope if b equals 0. So in this case, my rule is y equals 2x, and it is a proportional relationship. In the next one, it says, this says, is this a proportional relationship where x is the number of eggs and y is the number of cups of milk? Let's test it. And we did test it, and the constant of proportionality was 2. Now let's look at the next one. This is talking about number of servings and cost of Coke. So if I do 30, this is y over x. If I do 30 over 10, I get 3. If I do 50 over 20, I get 2.5. And if I do 70 over 30, I get 2 1/3. So this is not a proportional relationship. There is no constant of variation, so it's just not proportional. And if I was to figure out a rule, let's look at this. As y changes, y is going up by 20. This is going up by 20. This is going up by 10. If I look at the change in y over the change in x, I get 20 over 10, which is 2. So I know this is y equals 2x. But then when I plug in x, which is 10, I get y equals 20. To get it to 30, I have to add 10. So my rule is y equals 2x plus 10. And let's see if this works for the other ones. So I'm suggesting this is my rule. And let's see if it works here. So does 30 equal 2 times 10 plus 10? And the answer is yes. Does 50 equal 2 times 20 plus 10? And it's yes. And does 70 equal 2 times 30 plus 10? Yes. So this is my rule, and we see that b does not equal 0, thus confirming this is not a proportional relationship. Now, if I was to graph this, it would not go through the origin. Okay, let's look at the next one. It says, I'm going to compare the number of servings to the cost of cakes. I'm going to look at, that was cake, and I read it as Coke. Okay, cost of cake based on the number of servings. So we did that. It's not a proportional relationship. So here, okay, we're looking back to these tables that we did before and to the rules that we came up with. So here, when I do y over x, this all equaled 2. Thus, my equation was y equals 2x. When I did this one, this ended up being 3, 2.5, 2 1/3. It was not a proportional relationship, but my equation was y equals 2x plus 10. Now, when I graph both of these, this one goes through the origin. And when I graph this, if I count by twos, let's say 2, 4, 6, 8, 10. And if I go like this, it does not go through the origin. Here, b equals 0, and here b does not equal 0. So one way to think about proportional relationships is that the ratio between two variables will be equivalent. Another way to think about it is that one variable will always be some constant times the other. The constant is the constant of proportionality. If it's a straight line through the origin, or if it's in the form of y equals mx plus b, where b equals 0, then the constant of proportionality is the same as the slope. Okay, so now we're going to do some practice. So for number 1, it says, which relationships have the same constant of proportionality between y and x as the equation y equals 1/3 x? So I want you to stop the video and everybody try to do this on your own. We're trying to determine which one of these has this rule or has a constant of proportionality of 1/3. Well, I know if the equation is y equals 1/3 x, then the constant of proportionality is the same as the slope. I also know if there is a constant of proportionality, it has to go through the origin. So right away, this is not the correct answer because it does not go through the origin. Now, both of these go through the origin, but they have different slopes. I'm looking for a slope of 1/3, down 1/3. So this is definitely a possibility. This one has a slope of 3, so it's not 1/3 x. So that's not one. Now, they also give me information in a table. And when I'm given information in a table, I put y over x, and I see if it has a constant of 1/3. Well, right away, I see this is not going to work because negative 4.5 over negative 1.5 equals 3. So this does not work. Now I'm going to put y over x here. Negative 1.8 over negative 5.4, well, that equals 1/3. Negative 0.9 over negative 2.7, and that equals 1/3. 0.5 over 0.15, and that equals 1/3. And 0.8 over 2.4, that equals 1/3. So this is the other answer. So the answer is C and E. Let's look at the next question. It says that this graph shows the distance in miles that miles D, that a car travels in T hours. And they want to know if this represents a proportional relationship. Well, it is a straight line that goes through the origin, so the answer is yes. And is that all it asked? Is this a yes or no? Oh, okay. Explain why the graph does or did not represent a proportional relationship. It represents a proportional relationship because it's a straight line through the origin. Let's see if we can come up with the equation. Well, it goes up 100 over 2, up 100 over 2. So up 100 over 2 means the constant of proportionality is 50, and this would be y equals 50x. Okay, except here, because it starts at 0, we would have to say that x is the domain would be x is greater than 0, and the range would be x is greater than 0. So we're only looking at positive values here. Okay, let's turn the page, and we're going to do 2 more. Okay. This says the number of parts produced by 3 different machines are shown in the table. Only one of the machines produces parts at a constant rate. Which equation represents y, the number of parts produced in x minutes, for the one machine that produces parts at a constant rate? So, which one of these produces parts at a constant rate? Well, the way to do that is x is the minutes, and our possible y sub 1, y sub 2, y sub 3 would be the machine parts. So let's do machine Q. Machine Q would be 9 over 1, which is 9, 18 over 3, which is 6, and 27 over 9, which is 3. So machine Q did not work. Then we have machine R. 8 over 1, which is 8, 24 over 3, which is 8, 72 over 9, which is 8. So that would work, and the constant of proportionality is 8. 6 over 1 works. 18 over 3 is also 6. That works. But 52 over 9 does not give me 8. So the only machine that works is machine R, and that would be the rule. Okay, now the last problem, which again, I want you to stop the video and do on your own and turn it back on when you're done. This says the table shows the number of pages a student reads and how many minutes it takes the students to read those pages. Which statement best describes the relationship in the table? Well, before they even, we'll say that is x and this is y. I'm going to do y over x. Y over x is 9 over 4. And this is 13.5 over 6, which is 135 over 60. And now I'm going to divide by 5, divide by 5. 5 goes in 12 times here. 5 goes in to 13, 2, 27 over 12. Divide by 3, that's 9/4. Okay, so it took me a while to get there, but that's 9 over 4, 9 over 4. And 18 over 8 simplifies to 9 over 4. So here, y equals 9/4 x would be the equation. The constant of proportionality is 9/4, which is also 2.25. So it's 2.25 minutes. So the number of pages in 2.25 minutes. So I see that this says the number of minutes is proportional to the number of pages with a unit rate of 2.25 minutes per page. And that would be the correct answer. So the correct answer is B. Okay, and that's the end of this video.